All right, ladies and gentlemen, thank you for watching this. It took a lot of technical issues for me to get this video to you, so I hope you appreciate it. All right, so towards the end of class today, we wanted to get to talk about an algebraic procedure for determining whether a function's even or odd. We can sort of get an idea from the picture, from the thing that we're looking at, but we want to find out how can we actually tell if a function's even or odd just by algebra. Okay, so here is a procedure that we can follow that will allow us to determine whether a function's even or odd. So the first thing we want to do is we want to graph the function in our calculator and take a guess. We had a kind of a good feeling as far as what those pictures looked like, whether it was going to be an even or odd function. So we want to graph the function in our calculator and make a guess first. Once we have that guess, then we want to take and find f of negative x. We take all of the x's in our function and replace them with negative x's. Then we take and simplify that function. If we end up with the original function being the same as our negative x function, then we can say that f is even. All right, once we have determined that f is even, if it is indeed even, we can skip all the way to skip step 3, and then we don't need to worry about it. If it's not even, then we want to say, could it possibly be an odd function? So then we want to say, okay, well, I'm going to take my original function, and then I'm going to change all the signs on it. I'm going to make it all negative. Once we do that, we're going to simplify it and then compare it with the f of x function that we found, f of negative x function that we found up here. If our new function that we found is equal to the old function that we found, so if f of negative x is equal to negative f of x, then we have an odd function. Okay? If we have that situation where we have f of negative x, so the first function we found, is equal to the second function we find, then our function is going to be odd. All right, and then if neither of those above steps results in a true statement, so we don't find something that's even and we don't find something that's odd, then the function is neither even nor odd. And neither is generally spelled with an I, not nether. But hey, that is the breaks. All right, so let's take a look at an example. All right, f of x equals 5x to the 7th power minus 6x cubed plus 2x. So our first step was to take a look at our calculator and graph it. Take a look at our calculator and graph it on there and see what we get, what it looks like. So I've taken the liberty of going ahead and typing our function into the calculator for us. So we see that y sub 1 is going to be the same thing as our function right here. So those two things are the same. So when we graph it, we get something that looks like this, which is a little bit on the gross side. So what we can do is we can modify our window. It doesn't seem to go out much past like 3 or 4. So we're going to change our x. So we're going to change and hit this window button. And when we do, it's going to ask us what we want our minimum x to be and our maximum x to be. So if we take a look again at our function, we could say it's not going to go much past 3. So let's do that. Let's change our x minimum to -3 and our x maximum to +3. Then we'll hit the graph button. So hopefully we get a little bit better picture. And when we do, we see something that looks like this sort of neat little shape right here. So that is then going to say, well, I kind of feel like this looks like most of the odd functions we looked at today. Because it feels like if we rotated it around that origin, then we could say, yeah, this is going to be odd. This is going to end up landing in its same spot when I rotate it 180 degrees. But we want to check to see if it is indeed odd algebraically. So we take a look at our function. The first thing we want to check for is whether it's even or not. All right, so I'll leave that function up there so that you can take a look at it. We want to see if it's even or not. So we're going to take and plug in f of negative x. So when we do that, f of negative x, we used to have just an x. Now we have negative x. So we're going to take and we're going to say, okay, everywhere I see an x, I'm going to plug in negative x. 6 times, that is a negative x cubed minus 2 times negative x. And I don't know why I wrote a 7, but there's a negative x. Okay, so now we want to take and simplify our function. So f of negative x is going to be 5 times negative x times itself 7 times. We're going to have 7 negatives, which is going to leave us with a negative x to the 7th. Negative times a negative is a positive, so we have 3 pairs of negatives and then 1 left over to end up with our negative guy right there. Okay, so then minus 6. Again, we have a negative x here that we're multiplying by itself 3 times. So negative x times negative x times negative x is going to be another negative x cubed. And then minus 2 times negative x. All right, so let's move some stuff around. If we multiply all these things together, we have negative 5x to the 7th minus plus 6x cubed. I took this negative and then hit that with it. Plus 6x cubed plus 2x. Again, I took this negative and then I hit that negative with it. So f of negative x, we now have to say, is this thing equal to our original function? Well, if f of x equals negative 5x to the 7th plus 6x cubed plus 2x, negative 5x to the 7th plus 6x cubed plus 2x, well, that's not our original function. So we can say that it's not even. All right? Because it's not the exact same thing as our original function, it's not even. Not even. So now we move on to step 3 of the list that I showed you earlier. So we want to say, all right, well, I'm going to take a look and see what negative f of x is. So what we can do is we can say negative times our original function, 5x to the 7th minus 6x cubed minus 2x. So then I'm going to take and distribute this negative into this parentheses to all of these terms and end up getting that negative f of x equals negative 5x to the 7th plus 6x cubed plus 2x. So once we do that, we want to check this f of negative x function against our f of negative x function. And we end up with, there should be a negative on this 5. I'm not sure where it went, but it ran away. I apologize for that. There, negative 5x. So if we take a look, we see that our first term, negative 5x to the 7th, negative 5x to the 7th. Then we also have 6x cubed, 2x, and 2x. These two things are identical. These are the exact same function, which is great for us because that means that these two are the same. And when those are the same, that means that it is an odd function, which matches our guess from our graph. Okay? So that's how we go about this. We're going to take and check it first with our calculator. Then we're going to take a look and algebraically plug in negative x for every single x we see in our original function. Then, if it's still not the same function, we're going to take a negative of our original function and see if this guy matches this guy. If they do, it's odd. If neither of those work, then it's neither of the two functions. Okay? So let's take a look at another problem. Come on, swipey, swipey. All right. So this one says 5x to the 6th minus 3x to the 7th, or 3x squared, excuse me, minus 7. Again, I've kind of taken the liberty of going ahead and doing our first step for us and putting it in the calculator. So I'm going to turn this one on. And we have 5x to the 6th minus 3x squared minus 7. So we're gonna, I'm going to zoom 6 to get our original window back. And then it's going to graph that function. Now it kind of looks like that function might be able to be folded on that y-axis and land on top of itself. But we want to make sure algebraically. So again, it kind of looks like it might not go much past 3. So let's go ahead and modify our window to be negative 3 to positive 3 again, just so we can get a little bit better picture of what's happening here. All right, so it comes down. So yeah, it really looks like we might be able to fold it on that y-axis. But we want to prove it algebraically. So let's do that. We made our guess. That was step 1. Step 2 is we need to plug in f of negative x. So everywhere we see an x, we're going to plug in negative x. So 5 times negative x to the 6th power minus 3 times negative x squared minus 7. All right? So then, if I have negative x times 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 negative x, or 6 negative x's, well, let's just draw that out. What's that look like? Negative x times negative x times negative x times negative x times negative x. Let's see, there's 1, 2, 3, 4, 5 times negative x. I apologize that those look so crappy. But these two guys, they make an x squared. These two guys, they make another x squared. But these are both positive x squareds. And then these two guys make another positive x squared. So positive x squared, positive x squared, positive x squared gives us just x to the sixth. So we have 5 times x to the sixth minus 3 times negative x, which is going to be a positive x squared, and then minus 7. So if we take a look at this function that we just got out, and we compare it to our original function, we see that those two things are identical. So since our original function f of x is equal to our new function f of negative x everywhere, then our function is even. Yay! We got an even function. Okay? And again, that hopefully matches your intuition by what you saw on that calculator. Okay? So let's take a look at one last example, and then I think you'll have the ability to do this on your test review. So if we take a look at this even and odd algebraic example, where again, step 1 is always going to be to graph it. All right? So again, I already have it typed in our handy dandy calculator. So I'm going to turn this graph on and then make our window back to normal. Okay? So now we have this sort of weird squiggly thing happening here. And it kind of looks like it might be able to rotate around the origin, but it kind of looks like it might not. So it might be odd, but it might not. I can pretty much say that if I fold it on this y-axis, this part of our graph right here is going to end up over here. So it's going to end up on stuff that's not our original graph. So I'm going to guess that it's not even, but I think it might be odd. Maybe. We'll see. All right. So let's take a look. Our first step is to check and see what we think. I think it might be even. We don't know. We'll find out. But then we want to say, all right, is it, or excuse me, I think it might be odd, but let's check and see. First, we want to check and see if it's even. I don't think it will be, but let's check. So 7 times negative x cubed plus 4 times negative x minus 2. All right. So then, if I take this this negative x and multiply it by itself 3 times, negative x times negative x times negative x, well, these two make a positive x squared. So I have a positive x squared times a negative x. So positive times a negative is going to be a negative x cubed. So this guy right here is going to be 7 times negative x cubed. Then 4 times negative x is going to be negative 4x and then minus 2. And then we do some more cleaning up, and we get that negative 7x cubed minus 4x minus 2 is our function f of negative x. So far, so good? Okay, cool. So we want to ask, is this function that we found, f of negative x, is this function that we found, f of negative x, the exact same thing as our original function that we started with? Well, right from the get-go, negative 7x cubed is not the same thing as 7x cubed. Those two are different. These two are different. The last term is the same, but if there's any kind of difference at all, they're not equal to one another. So it is not even. Not even. So then we want to take and look and see, could it be odd? So we want to check and see, all right, what is negative of f of x? What if we take the opposite of that function? So that's going to be the same thing as negative times our original function, 7x cubed plus 4x minus 2. And then we're going to distribute that negative into our function. When we do that, we get that negative f of x is going to be negative 7x cubed minus 4x plus 2. So in order for this to be an odd function, this f of negative x function, or this negative x function, has to be identical to this f of negative x function. If we take a look at the first term, we have the same negative 7x cubes. We have the same negative 4x's, but we end up with a different last term. Because this one last term is different, this thing is not odd either. So this is not odd. Okay? Since it's neither even nor odd, it is a neither function. It is neither even nor odd. Okay? So I hope that helped with the algebraic explanation of how we are going to be dealing with these functions. If you have any questions, again, please find me. I'm always here for you. So feel free to come by and ask some more questions. But with that, I'm out. I will post this onto Classroom right now. I apologize for the tardiness. I'll see you soon. Okay, bye.